so we're going to tie everything together and maybe start figuring out why part of Molly's family has red hair and why some of them don't. Okay? Punnett squares. As you can see, we got our terms on the board over there. That's kind of what we're going to hit. Some of them look familiar, some of them don't. So let's do a little review here real quick. And we're on. First thing, blank on your notes. Now everything up here in blue is a blank on your notes here at the beginning. And an allele, if we remember what an allele is, each gene of a gene pair. And we know they may or may not be the same. Pea plants. What color of flowers could they possibly have?
White and purple.
Purple and white. And if the alleles were the same, they might be both purple or they might both be white. Or they may not be the same. One could be purple and one could be white, and that's where we ran into a problem that we didn't know what color flowers they were going to have, right? So let's keep going. Hybrid. What does hybrid mean? Trevor?
It means like it's not of one dominant kind.
So it means?
There's two, one dominant, one recessive.
So two different alleles, one dominant, one recessive. Here's our example. Remember our letters for dominant, recessive, uppercase and lowercase. There's our example. But now we're getting a new word. Heterozygous. Everybody say that word.
Heterozygous.
Heterozygous. So we'll say it again. You're going to say it a lot here in a few minutes.
Heterozygous.
Heterozygous. So hybrid also means heterozygous. Hetero, that prefix hetero means different. Means different. This is probably what you're going to hear from now on, 7th grade, 8th grade, high school. Okay? Heterozygous and hybrid. One dominant, one recessive. What was our other one? If it's not hybrid, it is
Pure.
It's pure. So we also have terminology for that one either. Pure means that they're both what?
Dominant.
They're either both dominant or both recessive. And here again, here's our examples with our letters, 2 uppercase, 2 lowercase. This is called homozygous. Everybody say that.
Homozygous.
Homozygous. Prefix homo means?
Different.
Not different. Same. Prefix homo means same. Alright, so we have our alleles. They can be the same, they can be different, which means they could be hybrid heterozygous or they could be pure homozygous. Uppercase letters represent what kind of a trait?
Dominant.
Dominant trait. And again, this is all pretty much review for now. What kind of letters are represented by a dominant trait?
Capital.
An uppercase letter. Uppercase letter. Anybody not ready? We good? Alright, anybody not ready? If it's not dominant, then it's probably recessive. And recessive is the gene or the trait that gets what?
Mask.
Gets covered up or masked over. So that if there's a dominant trait there, can we see the recessive trait?
No.
No. What kind of letter is it represented by? A lowercase letter. A lowercase letter. So that's all kind of review. You guys are really great at that. Ready to go on? Alright, so this might look familiar also. If a dominant allele is present, we know that if they're both dominant alleles, what's the trait that we're going to see? Dominant. If it is, what is this? Hybrid or pure?
Hybrid.
Heterozygous, homozygous?
Heterozygous.
Heterozygous. So if it's heterozygous, we've got one dominant allele there, so it's going to do what, Joseph?
It's going to
It's going to mask that recessive allele, so what trait are we going to see? Dominant trait. The only way we're going to see recessive is if we have
both
two
pure
recessive alleles. That's the only way we're going to see that recessive trait. So, we got some more terminology. 2 more words. Genotype. Everybody say that.
Genotype.
Genotype. And again, genotype in the next one that we're going to see. You're going to hear that a lot starting in 7th grade, all through high school biology too. Genotype is the genetic makeup. And here's what we're talking about, the combination of alleles. Can I see the genetic makeup of Cooper's hair? We know he has red hair, right? But can we see this?
No.
No, we can't see this. We don't know what 2 alleles he got from his parents. Can I see what Molly's genotype is for her hair color? No. But what can I see?
Hair color.
Which is?
Brown.
I can see brown hair. I don't know what this is, but I know what that is. Phenotype. Everybody say phenotype.
Phenotype.
Phenotype. The phenotype is what is visible or what you can see. So I can see Molly's hair color phenotype, which is what?
Brown.
Brown. Can I see her genotype?
No.
I know it's brown, but I don't know what alleles
brown?
that she got from her parents. So I can see Cooper's what?
Phenotype.
I can see his phenotype, which is red hair, but I can't see his genotype, which is this combination of alleles. You need to know those two, so you might want to put a star next to them. Definitely need to know the difference between these. We'll be on the test on Thursday. So we ready to practice?
Yeah.
So let's practice. All right. Example. Let's say that brown eyes are a dominant trait. So the combination of alleles that would show the dominant trait would be 2 uppercase B's. And what do we call this? Dominant, pure, hybrid? Pure, heterozygous, homozygous.
Heterozygous.
Homozygous, same. Dominant or recessive?
Dominant.
Dominant because there's at least one dominant allele there. Pure, hybrid? Hybrid. Heterozygous, homozygous.
Heterozygous.
Alright, get the routine. The only way we're going to see the recessive trait, not brown eyes, would be 2 lowercase. So this is recessive, dominant, or pure, hybrid? Pure, heterozygous, homozygous. Homozygous, because they're both the same. Alright, so let's do one. Let's change the smartboard stuff around. Where's my pen at? There we go. Let's go blue. Alright, so let's say in this example, we're talking eye color. Mom has what color eyes?
Brown.
Brown. Is she dominant or recessive?
Dominant.
Pure, hybrid?
Pure.
Heterozygous, homozygous?
Homozygous.
Homozygous because they're the same. What about Dad? What color eyes would he have?
Brown.
Brown. Dominant or recessive?
Dominant.
Pure, hybrid?
Hybrid.
Heterozygous, homozygous?
Heterozygous.
Heterozygous because they're different. Alright, so let's do that combination thing again. See the example on your paper there? You're going to do the same thing on your paper that I'm doing up here. So let's say that we're going to combine those 2. What's the possibility for this offspring if these 2 alleles combine? Dominant or recessive? Dominant. Pure, hybrid?
Pure.
Heterozygous, homozygous?
Homozygous.
What color eyes?
Brown.
Brown. So the first possibility for the offspring, brown eyes. What color eyes do the parents have?
Brown.
Both have brown. Alright, so what about those 2? What color eyes?
Brown.
Brown. Dominant or recessive?
Recessive.
Dominant, because we've got one dominant allele there, which covers this one, so it means it's going to be dominant. Pure, hybrid?
Hybrid.
Heterozygous, homozygous?
Heterozygous.
Okay, what about those 2? What color eyes?
Brown.
Brown. Dominant or recessive?
Dominant.
Pure, hybrid?
Pure.
Heterozygous, homozygous?
Homozygous.
Homozygous, because they're both the same. What about if those 2 happen to combine in fertilization? Brown? Or not brown? Brown. Dominant or recessive?
Dominant.
Pure, hybrid?
Hybrid.
Hybrid. Heterozygous, homozygous? Heterozygous, because they're different. Okay, so Mom had what color eyes?
Brown.
Dad had?
Brown.
150.
What color is that?
Brown, 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 brown.
100%. But let's break it down just a little bit. What percentage for dominant pure?
50.
50? 2 out of 4?
Yeah.
Everybody agree with that?
Yeah.
2 out of 4, so 50%. What about dominant hybrid? 50. 2 out of 4, right? 50%. What about recessive pure? 0. There's not any for the recessive trait. So this would be 0%. Right, so you need to have all of that on your paper. Give me a minute to catch up. Down at the bottom left, make sure you got all your lines drawn and your percentages in there.
There's an app on there, it's called like genetics or something, and you like scan it and it puts like brown hair and
We're going to look at that a little bit more tomorrow. You see, you've already previewed that, so some of this is making a little bit of sense, isn't it? All right, this is all great, right? But could we make it easier to read and understand?
Yes.
Sure we could. You may not ready?
What about like blonde hair?
What about what?
Like blonde hair and red hair.
Let's finish, and then we'll come back to hair color explain. All right, that's where a Punnett Square comes in. Punnett Squares make all of that other information a little more organized and a little easier to understand. So we're still going to look at eye color here, okay? And brown, in my example, is still the dominant trait. Pure or hybrid?
Pure.
Heterozygous, homozygous?
Homozygous.
Pure or hybrid?
Hybrid.
Heterozygous, homozygous?
Heterozygous.
Dominant or recessive?
Recessive.
Recessive, 2 lowercase letters, recessive. Pure or hybrid?
Pure.
Pure, heterozygous, homozygous?
Homozygous.
All right, so in my example, brown eye color is going to be dominant and anything else is going to be recessive. So let's look at 2 parents and figure out this Punnett Square here. Let me get my examples. Let's say that the first parent, we'll just say this is mom. What is she, dominant or recessive?
Dominant.
Dominant, because it's got 1 of each. And pure or hybrid?
Hybrid.
Heterozygous, homozygous.
Heterozygous.
And let's say that dad is the same thing. He's also dominant. He's also pure or hybrid? Hybrid. And he's also heterozygous or homozygous?
Heterozygous.
So 2 brown-eyed parents, let's see what the possibility is for the offspring. So instead of drawing all those lines and penciling it in and kind of confusing yourself, we're going to use a Punnett Square instead. And so what we're going to do is kind of like a grid, kind of like tic-tac-toe, kind of a grid. So I'm going to take these 2 right here, and where they match up in the box, I'm going to pair them up just like that. And now I'm going to take this one, and I'm going to go all the way across here and match it up with this one. And right in the box. And I'm going to take this one, and where they meet, see how they're meeting? I'm going to write that in the box. And we'll take these last 2, and where they meet, in our grid, in our box, and match that up. A lot neater than drawing all those lines, right?
Oh.
Much more organized. So now let's look at these 2 brown-eyed parents and figure out the percentages of the offspring. So dominant, pure, what's our percentage? Each one of these boxes is what?
25.
25%. So dominant, pure?
25.
25, because we've got 1 out of 4.
75.
75, because we have dominant here and dominant there. So overall, it would be 75%. So this is going to be big for terminology. So look at your box here and answer my question. What is the percentage that the offspring could have brown eyes? Raise your hand when you have an answer. What is the percentage that the offspring could have brown eyes? Taylor? 100? Can't be 100.
75.
It'd be 75%. Did I say either dominant pure or dominant hybrid? What was my question?
Well, they have brown.
I just said flat brown eyes, didn't I? So is this brown eyes?
Yes.
And is that brown eyes?
Yes.
So what's the percentage that the offspring could have brown eyes?
75%.
75%. All right, look at the difference in this question. What is the percentage that the offspring could be dominant hybrid? Dominant hybrid. James?
75.
75? Joseph?
50.
What's dominant hybrid? Here's our dominant hybrid right here, so it would be 50%. You have to know that terminology. You're going to see questions like that on your worksheet tomorrow that we're going to do in class, and you're going to see questions like that on the test on Friday, not Thursday, Friday. Break it down. Next question. What is the percentage that the offspring could be recessive pure? Logan?
25.
Recessive, pure, same, 25%. What is the percentage that the offspring could be recessive hybrid?
50.
Trevor?
50.
Recessive hybrid? Joseph?
0.
Why?
Because there isn't brown. It's just hybrid.
Can it be a hybrid if it's recessive?
No.
To see the recessive trait, what do you have to have?
Pure.
You have to have both recessive alleles. What does hybrid mean?
Opposite.
It means they're different. Can it be recessive if it's a hybrid?
No.
Oh, I tried to trick you there, didn't I? It's all about terminology. Dominant, recessive, pure, hybrid, heterozygous, homozygous. Okay? Next question, one more. What is the percentage that the offspring could be homozygous for something other than brown hair? Homozygous for something other than brown hair. Katie?
Black.
I don't want a color. Percentage. Trevor?
25.
And where are you getting that from?
Because there's
Homozygous means same. Other than brown hair means other, which would be this right here, 25%. Now, am I going to ask you something that complicated? No. But you definitely have to know dominant, recessive, pure, hybrid, heterozygous, homozygous. Got to know those words. So let's do another one. Everybody got that filled in?
Yeah.
On your paper with percentages? All right, let's do another one. All right, look at what we're looking at now. What trait are we looking at?
Height.
Plant height. So now we're not talking about humans, we're talking about plants. And what's the trait?
Height.
Height. So in my example up here, what is the dominant trait? And how do you know that, Jace?
Because 2 out of 50% of or 75% is
Because they have what kind of letters?
dominant.
They have uppercase or dominant letters. What's the recessive trait?
Lowercase.
Short, because we see the lowercase letters, it's short. Make sense? All right, so let's look at our first parent plant. Here's our first parent plant. Tall or short?
Tall. Tall.
Tall. Dominant or recessive?
Dominant.
Dominant. Pure, hybrid?
Hybrid.
Heterozygous, homozygous?
Heterozygous.
Heterozygous because they're different. And our second parent plant is tall or short?
Short.
short, dominant or recessive.
Recessive.
Recessive, pure or hybrid.
Pure.
Pure, heterozygous, homozygous.
Homozygous.
All right, so we have a tall parent and we have a short parent. Is it possible for the offspring to be tall? Is it possible for the offspring to be short?
Yes.
Let's find out. Okay, we're going to take these two right here, match them up. They give us that. Take this one and this one, match those up. Let's take these two, match them up right here. Let's take these two, match them up right there. So let's go through all the possibilities. Our first possibility is what? Dominant or recessive? Tell me something else. Pure hybrid? Pure. Heterozygous, homozygous.
Homozygous.
So with this tall parent plant and that short parent plant, is it possible to get a dominant pure offspring?
Yes.
No.
You see two uppercase T's anywhere over there?
No.
No, it is not possible. So what's our percentage?
0.
0. What about dominant hybrid?
50.
50? Everybody agree with that?
Yes.
Because we have 2 out of 4, 50%. What about recessive pure?
50%.
50%, because we've got 2 out of 4. This right here, this is your quiz on Thursday. It's not going to be plants, it's going to be guinea pigs. Okay? But this is what you're going to have to do right here. It's going to tell you what's dominant, what's recessive. You're going to have a Punnett Square. You're going to have to fill it in. We call these making the crosses. Okay? You're going to have to make the crosses, figure out your percentages.
So how would you make it, like, how would you start off?
Just like we did here. It was all blank. One parent will be there, one parent will be there, and you'll write in your crosses, figure out your percent. I mean, this is it, exactly what you're going to do on the quiz on Thursday. It's just going to be guinea pigs instead of this. But
On the parents, how do you know which one to choose, like short and tall?
those are just examples that I have on my paper.
Oh, so
I didn't put them on your paper because I didn't want you working ahead and not listening.
Oh.
Okay? I can do any combination that I want. Okay, so I picked the different types
Is
of
it
parents.
gonna be like that on test? You just
Yeah.
pick some.
Well, we'll talk about test maybe tomorrow or after the quiz, so you have a better idea. Okay. Melissa, how do you know which one's the cross on the chart? You mean here? Okay. Watch. Don't do this on your paper, but watch what I do here. See how those intersect, and how this intersects, and that intersects, and that intersects. It's like a grid. Have you ever played Battleship before?
Yeah.
Okay, G3, find G and 3, same thing. Match. Make sense? Okay. Alright, so don't make those marks on the paper, you won't be able to read it. One more. Let's do one more. Still looking at plant type. So this time, my first parent is tall or short?
Tall.
Dominant or recessive?
Dominant.
Pure or hybrid?
Hybrid.
Heterozygous, homozygous.
Heterozygous.
My second parent plant is the exact same thing. So we have two, somebody describe these two parents for me. They are dominant, hybrid, and heterozygous.
On the test, is there gonna be like telling us what each parent is gonna be?
Yeah.
There might be like a question on that, there'll be a question on the quiz, one that you're going to have, like a little mini essay questions where you're going to have to explain it. And on the test, it might say, what is the possibility of offspring that is recessive if you cross two dominant heterozygous parents? So you're going to need to know that dominant and heterozygous means what? Same or different? different, and you've got two of them. So you have to set this up, figure out the percentage, and then I asked what was recessive. Okay. It's going to be doing this exact same thing here, but it's going to be a word problem instead. Makes sense a little bit? You're going to get lots of practice tomorrow with that. All right, so let's make these crosses. So here, what kind of offspring are we going to get? Raise your hand. Somebody describe that offspring to me. Go, Haley.
It's pure.
Pure.
Homozygous.
Homozygous. Dominant or recessive? Okay. Everybody agree with that?
Yes.
All right. Let's take this and this. Somebody raise your hand and explain that offspring to me. Lacey?
It is dominant.
Dominant.
It is heterozygous.
What?
Heterozygous.
Heterozygous.
Yeah. It's
Pure hybrid's what you got.
hybrid.
Everybody agree?
Yes.
Everybody agree? Okay, how about these two right here? Tail?
Dominant.
Dominant.
Heterozygous.
Heterozygous.
Hybrid.
Hybrid. Everybody agree?
Yes.
And what about our last two here? Who wants to explain that one? Ethan?
Dominant.
Dominant. Are you sure? Look at our letters. Recessive.
Pure.
Pure.
Heterozygous.
Homozygous. Same. Everybody agree with that?
Yes.
All right, so let's look at our percentages. With these two tall parents, is it possible to get a dominant pure offspring?
Yes.
What's the percentage?
25%.
25. 1 out of 4. Two tall parents, is it possible to get a dominant hybrid offspring?
Yes.
Percentage? 50. With these two tall parent plants, is it possible to get a short offspring?
Yes.
25%.
25.
Not a very good chance, but it's still a chance. You guys doing good? Getting the hang of it?
Mhm.
Ready to see something a little bit, same thing but a little bit different? When you're ready, flip the paper over. You ready? These are called unichromo dragons. Obviously, what trait are we going to be looking at?
Tail.
Their tails.
Yeah.
Mom has what kind of a tail?
Swirly.
Curly. Dad has a
Straight.
straight. What can we see here? The genotype or the phenotype?
Phenotype.
We can see the phenotype. We can see curly and we can see straight. Do we know which one is the dominant trait?
Yes.
Because we can't see their what?
Genotype.
We can't see their genotype. We can't see what alleles they have. So this would be kind of like the red hair and brown hair thing in the Cummins family. We can see it, but we don't know what the genetic makeup is. But what if I do that? Does that help any?
Yep.
Looking at that information, what leads you to believe that one or the other is the dominant trait?
Mother.
Colton? Go ahead and tell me what you were going to say. Why do you think mother?
Because it's it has a capital T.
Right there. There's mom's genotype, and she has at least one what? She's got at least one dominant allele, so it passed this one. And so what trait do we see? Curly. So that means straight is going to be the what?
Recessive.
The recessive trait. So quickly, on your paper there, down at the bottom somewhere, sketch that information out, because we're going to go to the next screen and you won't be able to see it. So mom has the dominant trait, curly, and her combination is uppercase, lowercase. She's a hybrid. And dad has the recessive trait, straight tail. So copy that information there on your paper real quick. And we'll move on to the next slide. So, what do you notice kind of different about this setup than what we've seen previous? Looks kind of different, doesn't it? But is it the same information?
No.
We're still getting the same information. As we start on the bottom, now we have 4 baby dragons. And they have no tails, poor little guys, or girls, whoever they are, okay? They have no tails. We have to figure out the possibilities. So it's going to be a combination of those alleles. So if you look on your paper, now we kind of have some word problems. But look at the very first question. It says number 1. During reproduction, the sex cells with chromosomes M1 and F1 combine to form an embryo. Does that even sound like what we've been talking about before?
No.
Not really, but is it the same stuff that we've been talking about?
Yes.
They just use different terminology. Look at it again. The sex cells with chromosomes M1 and F1. They took one of mom's and one of dad's, and they combined during what's that process?
Reproduction.
Not
Yes,
really.
meiosis. Meiosis.
The meiosis is the sex cells, and when the sex cells combine, they join together. What's that called?
Fertilization.
Fertilization. And they combine to form a what? An embryo, which is a new organism. They just worded it different, but are we talking about the exact same stuff?
Yes.
All right, so let's look at it. M1 and F1. So what's M1? Uppercase or lowercase t?
Uppercase.
Uppercase. What is it? T?
Yes.
And what was the other one? F? F1? Is that what it was?
Lowercase.
Lowercase t. So baby dragon number 1, let's do it by steps. Little letter A. Somebody read little letter A for me. Haley, read little letter A there under number 1.
Which alleles are on each of the chromosomes?
All right, so which alleles?
TT.
Uppercase T, lowercase t. So that's what you're going to write on your paper for little letter A. It's wanting to know the combination. Uppercase T, lowercase t. Little letter B. Cassie, read little letter B.
Will the baby dragons have a curly tail or straight tail?
So based on this information, what kind of tail is the baby dragon going to have? Read.
Curly.
Everybody agree? Curly? Everybody agree?
Yes.
So write curly on your paper. And then what does little letter C say?
Draw the tail.
Draw that tail on baby dragon number 1. So draw a curly tail on baby dragon number 1. Alright, moving on to baby dragon number 2. During reproduction, the sex cells, what 2 sex cells are combining now?
M1 and M2.
Okay, what's M1?
Capital T.
Uppercase T. And what was the second one?
Lowercase t.
Everybody agree? Lowercase t?
Yes.
Alright, so there's our combination for little letter A, uppercase and lowercase. What kind of tail is that baby dragon going to have?
Curly.
Curly, so write it down. And Sydney, come on down. You're going to draw that tail on baby dragon number 2. I shouldn't have to do all the work. That end right there, just like a pencil. Curly tail on baby dragon number 2. You ready for baby dragon number 3? It says during reproduction, what alleles are combining? What's our combination there? M2. What's M2?
T.
Lowercase t.
Lowercase t. And what's the second allele?
Lowercase t.
Lowercase t. Everybody agree with that?
Yes.
Write your combination down. What kind of tail?
Straight.
Straight. Lowercase, lowercase. Uppercase, lowercase. See this one here? Okay, what did we say?
Straight.
Straight. Molly? And draw a straight tail on baby dragon number 3. We're laughing with you, not at you, okay? You ready for baby dragon number 4? Okay, what's our combination down there?
M.
T, lowercase t,
T.
lowercase t, lowercase t.
2 lowercase t's. Everybody agree with that?
Yes.
What kind of tail?
Straight.
Straight. Draw a straight tail on.
So it's like the people on the pregnant tree. Will that work?
Not that bad.
Yeah. Thank you, Joseph.
It's not a straight line.
Alright, so, did we do the exact same stuff that we just did before?
Yeah.
We just did it differently, didn't we? Terminology was different. Remember when we first started this genetics units and I said, knowing what the words mean is going to be huge?
Yeah.
So let's go back through here. Dominant or recessive?
Dominant.
Pure or hybrid?
Hybrid.
Heterozygous, homozygous?
Heterozygous.
Dominant or recessive?
Recessive.
Pure or hybrid?
Pure.
Heterozygous, homozygous?
Homozygous.
Alright, let's finish those conclusion questions down there. Which allele is dominant? Curly or straight?
Both.
Curly.
Curly. Write it down.
Oh, that's right.
We're at the bottom of the page down there. Number 2, which baby dragon or dragons are pure for the straight tail?
2.
Which baby dragons, not how many. Remember, we gotta make sure you know what it's asking you, Haley.
Dragon number 3 and 4.
Everybody agree? 3 and 4?
Yes.
Okay, 3 and 4. Number 3, which baby dragon or dragons are hybrids for the curly tail?
2.
Katie?
Dragon 1 and 2.
1 and 2. And are there any baby dragons pure for the curly tail?
No.
No.
Ready?
Ooh,
Time for...
Again.
I don't know what the name of my game show is. I hadn't thought of it. Alright, so...
Let's just say that. Punnett
Square.
Fair game.
Punnett
Square.
We should name
The
it
gene game. There we go. Welcome to the gene game. And since Michaela named the game, Michaela gets to be the host at the moment. The hostess with the mostest.
Hello.
So, let's turn around because you're going to be like Vanna. Okay? You know Vanna White on Wheel of Fortune? Okay, never mind. Alright, so here's what we're going to do. And right now you see the dice. And we have a combination of alleles there. So what do we have right now? Dominant or recessive?
Dominant.
Pure or hybrid?
Pure.
Heterozygous, homozygous?
Homozygous.
So, touch that first dice on the left. Just touch it.
Mine needs to touch the air.
It's on color.
Oh, it's on color. That's right. Come back over here to the arrow. Touch on the arrow. That's
You
right.
can.
Alright, now touch on that dice.
Touch the arrow.
The air.
No, don't touch the arrow. You
Oh.
don't want to touch that. Alright, we're not working. What are you doing to? There we go.
Double tap.
Now, double tap that one.
Dub stuff.
Now what do we have? Dominant or recessive?
Recessive.
Pure or hybrid?
Pure.
Heterozygous, homozygous?
Homozygous.
Again. Oh, you're supposed to say very good, audience. Walk in.
You came up with the name. You put it on yourself.
Oh, dominant or recessive?
Recessive.
Pure or hybrid?
Pure.
Heterozygous, homozygous?
Homozygous.
One more time.
Same. Oh, it's actually different for ones.
Oh, dominant or recessive?
Dominant.
Pure or hybrid?
Hybrid.
Heterozygous, homozygous?
Heterozygous.
So let's see how well you're ready to do. Get your, oh, you don't need your crayons yet. Alright, so I have a combination here. I have a combination have part of the board covered?
Whoa.
How many people are scared there's something underneath there that's always going to be fun, I promise. Alright, so, let's go. Ethan, come here. That first combination up there, the A's, double tap on each of them. So let's get our combination there. I didn't say pound on it, I said double tap on it.
Tap it.
It doesn't like these then.
Tap it. I think
the arrow.
Oh, there we go.
D.
There we go.
Good
So
job.
there's our
Good
first
job.
combination there. We have that. Jake,
Bye-bye.
you're up next. Let's get a combination for the B's.
Come on.
Great. There's our combination for the B's. Read. We got the C's. Let's get a combination for the C's.
You should have got the R's.
And Aubrey, you got the D's.
Probably the E.
Hey, something different.
Alright, so we have our combination now.
Oh, you already made it to do this that way.
Well, let's look at our descriptions here. We have a nose, ears, horns, and chest. If you know what this is, then you should be able to figure out which one of those traits it has. Notice I said which one of those traits it has.
What's it in?
It's a rhinoceros.
It's
That's scary. It's
Not scary. So here's what you're going to do. Get your crayons and your color pencils out. Crayon or color pencil.
I got both.
We have Happy Alien here. This is Happy Alien.
Where's the chocolate?
Happy Alien. Alright, first, everybody listen up here. First, put your name on this paper. Go to the top of the page somewhere. Put your name on it. Put your name on it, first and last name. So what you're going to do with Happy Alien, kind of looks like Kathy, doesn't it, when she says okay. Alright, so Happy Alien, you are going to color Happy Alien according to his traits. So these are going to be dominant or recessive. That's going to be dominant or recessive, dominant or recessive, dominant or recessive. You've got to figure out what this trait is and color him accordingly.
Does it matter what color we use?
Huh?
Does it matter what color we use? Oh.
Good. Alright, so when you finish with Happy, because he is happy. When you finish with Happy, what are you doing with Happy?
Throwing them away.
No. He will not be very happy if you throw him away. What are you going to do with Happy?
Turn them in.
Alright, everybody listen up. Listen up. When you finish with Happy, Colton, put your pencil down, listen. You're going to turn him into the pocket. When you turn him in, look here, I want you to turn him facing the wall.
But he won't be so happy.
But I will be. I want you to turn it facing the wall when you turn Happy in. Right
So
now,
no
make sure
one
your name is
knows
on your paper.
what-
Alright, after you finish with Happy, when you finish with Happy, you might have a little bit of time to get on your iPad. Go to Gene Screen.
Oh, yay.
Start previewing that. Now this is going to make a whole lot more sense since we've gone through this. Okay? Happy? Alright, got it? One more time. One more time. Color Happy according to dominant or recessive up here. What are you doing with Happy when you're finished?
Turning him in.
Turning him in, face to the wall, and then you can go to the iPad and get on what app?
Gene.
Gene Screen. Got it? Go.